Oh, hi, how are you doing tonight? This is another one of our fantastically exciting calculus videos. A little flipped instruction for you. Tonight we're going to look at section 1.1 from our book, which is all about functions. It's really an overview or a review in a lot of sense of functions. But let's get right to it and see what you remember and what you don't. Functions, definition of it. A function, and we're going to call that function f, and that really, it could be any letter, but f is what we typically use a lot of times. A function assigns each element, and those elements, we would call those x values. Those are just the things that we plug in. It assigns each element, and I'll change that to all the same color since x's belong to this first group here. So it assigns each element x of set A to exactly one element, and that's really important. Really important. I'm going to come back and hit this again a little bit, just a second here. But exactly one element. I'll explain more what that means in a second. So it assigns each element of set A to exactly one element, and now we're going to call those the y values of set B. And so what I mean by that is, let's say I've got a couple x values that I want to plug into a particular function, or into a particular equation, I guess I'd say. Alright, and so that's my set A. Those are the values I want to plug in. Alright. Well, when I plug those in, I'm going to get an answer then as a result of plugging them into the function. Now, if it's a function, then I'm going to get exactly one answer for every value that I plug into it. So you'll see that if I plug in 2, I'm going to get the answer 15 and nothing else. Alright? You might think that it always is the case, that you always get one value, and it is in most of the things that we see, but we will look at some equations, some graphs this year where that's not the case. So again, just to kind of expound on this, our set A, that's the things that are going into the function, the domain, the input, the independent variable, the x's. Alright, so that's the first part of a function, is you have to have things to plug in. And then set B, that's just the result. That's the end result here. So that's the range. I know you're familiar with the terms domain and range. It's the things that come out of the function as a result of you putting something into the function. It's the dependent or the y variables. So I hope that gives you just a little bit of a reminder about what a function is. And functions they come in, I mean, we can really talk about them in a variety of ways, and we will throughout this class. Functions can be expressed as words or sentences. I can describe a relationship between two groups of values. Alright, and that could be a function. You see that in story problems a lot. Alright, functions can be numbers, particularly ordered pairs. And so I could take those sets up above and create ordered pairs out of them. 0, 7, 1, 12, 2, 15. Those would be the ordered pairs of those sets. Obviously, functions can be expressed visually through graphs. So here's the graph of a cubic function, the typical S-curve. Alright, and what we'll do is in the following section we'll actually use this to look at if a graph is really indeed a function. Maybe you remember the vertical line test from Algebra 2. If not, no big deal, we'll talk about that in the next section. And then obviously functions can be expressed as equations, and that's where we really see a lot of them in this class, how to work with those. Another kind of point of review, hopefully for you, is just notation. What does function notation mean? What's it look like? Some people really get hung up on f of x. Just remember that f of x means exactly the same thing as y. So if I say y equals 3x minus 1, that is the same thing as f of x equals 3x minus 1. Okay? It just means what is the value of the function for some particular x. So if that x is a number, then what is the value of the function when I plug in that number and do math? If it's an expression, then it's a matter of me plugging in that expression. Alright, so again, just a reminder, y equals 1 minus x squared means exactly the same thing as f of x equals 1 minus x squared. They are one and the same. Okay. But we'll use the function notation more. Alright. Again, what does the symbolism mean? F is just the name. It's just the way that we name the function. So that's where it's better than y, because y represents every function. But now I can name this. This is the graph of f, or the graph of g, or the graph of m, or whatever that function might mean. F of x is simply the value of the function for some particular x value. So when I plug in x and I get an answer from it, that's f of x. Okay, so again, f of x is just the corresponding output, okay, for some given input. Hopefully you're able to evaluate functions. I'm sure you did a little bit of this work in the past. So let's say we've got a function g of x equals x squared minus 4x plus 3. So you should be able to evaluate g of 2. All that means is every time I see an x in the problem, I'm going to plug in a 2. Now if you notice, I always like to put my things that I'm plugging in parentheses. It's not a huge deal in this problem because 2 squared with or without parentheses is still 4. But it's a good habit to get into, especially as we do this next one now. Now I'm going to do g of negative 5. Real important you put that negative 5 in parentheses. If you don't, you might make the mistake of squaring 5 and then throwing a negative sign on the front of that. Okay, definitely a mistake there. Alright, so please be careful when you're plugging in these values that you're plugging in those for the x and doing all the appropriate work. What if we plug in variables, letters, like g of w? This just means that, again, every time I see an x, w is going to go into its spot. This one is not particularly difficult. You're going to see that it ends up looking exactly like the original function, but we've got w's in all those places. But that kind of sets the stage for our last one, which is going to be g of x plus 2. Alright, same premise. Every time I see an x, I'm going to plug in x plus 2. The only difference is that the algebra gets a little bit more difficult in this problem. To evaluate x plus 2 squared, I'm going to have to do FOIL on that, and make sure that if you're not great at looking at it and doing it, expanding it into x plus 2 times x plus 2. And when you do that, you get x squared plus 4x plus 4. Be real careful that you distribute the negative sign now with the 4 through the rest of that next parenthesis. So it's negative 4x minus 8. You can see that I got a positive 4x and a negative 4x. Those will cancel out. And when I'm done simplifying this problem, it's going to be x squared minus 1. Again, what does that mean? That is the value of the function when I plug in x plus 2 in for f. Next idea, and this is probably the one idea that might be a little bit new for you, so we're going to spend a little bit more time on this and try to explain it a little bit further detail, and it's piecewise functions. So I'll show you an example of a piecewise function here. So f of x equals, I'm going to use this big parenthesis here, or whatever, x squared plus 1 when x is less than 0, and then x minus 1 when x is greater than or equal to 0. So the best way to think about this is a piecewise function is simply a series of functions that all have their own specific domains. So what I mean by that is f of x is x squared plus 1, but only when x is less than 0. It's x minus 1 when it's greater than or equal to 0. So we treat them as multiple functions, but each of them has a restricted or a specific domain that determines when we use that particular function. Alright, so kind of the best way to start is look at a graph of this function. Okay, so I'm going to shade the top function, the x squared plus 1. I'm going to shade that red. Hopefully you look at that and recognize that's a parabola. So I'm going to go up one spot from the origin, have a parabola opening up. I'll shade the bottom function blue, and again I hope you recognize that as a linear function, so I go down 1, then up 1 over 1. And so those are the two graphs of those two functions. Now here's where the domain part takes over. I only want to use the top function when it's less than 0. So I'm going to erase everything to the right of 0. And in fact, I'm going to erase 0 because I don't really want that function when it's 0 either. So I'm going to put an open dot at 0 saying I'm going to get close to that, but I'm not going to include that value. And then for the bottom part, since I only want the values that are bigger than 0, I'm going to erase everything to the left of 0 there, but I'm going to include 0 now because that is part of that domain, and that right there is the graph of this piecewise function. You might want to go back and listen to that again if that was kind of quick. I can also plug values into this piecewise function. So if I plug in -3, I got to see, hey, which domain does that go with? Yeah, it goes with the top one. So that means I'm going to plug -3 into the top function. -3 squared plus 1 ends up being 10. But if I have f of 2, now 2 belongs with the bottom domain. And so now that's just going to be 2 minus 1. And I can do it with any number I want. It gets a little bit tricky when you use 0. You just got to make sure you know which domain 0 goes with. Hey, the last thing we're going to do tonight on this video is just an application with some functions. I'm going to read a little bit right now. You want to jot down any details you want. Let's say you work for the marketing department of the Arnold Palmer iced tea company, and you're experimenting with a new can for their iced tea that's a little bit different size. So let's say that with this new can, you've got a radius. Let's say we put it this way: the height is 4 times the radius. Okay, and if you remember, the volume formula for a cylinder is pi r squared times the height. So again, the height is 4 times as much as the radius. Okay, so two questions you got to do for me. The first one, I want you to rewrite the volume formula for the can, but I want you to write it as a function of the radius r. Now when I say that, all that really means is rewrite the volume formula so that the only variable you see in that is r. When you're done with that, I want you to rewrite the volume formula so that it's a function of the height h. Again, what does that mean? It just means write it so that the only variable you see in the problem is h. This would be a pretty good time to push pause and actually try to do this, and then when you're done, start the video back up and see how you do compared to me. I'll check back with you in a second. Alright, so how'd you do? Volume, remember, is pi r squared times the height. And so in this first problem, I want to plug in r everywhere I see an h. But remember my relationship. Okay, r doesn't equal h. Alright. 4 r's equal h. So when I take out h, I've got to plug 4r into its spot. And so when I rewrite that, that's going to be 4 pi r cubed. All it really means is I could find the volume of a can of this Arnold Palmer lemonade if I knew its radius. I could just plug the radius in and find the volume that way. Okay. But the second problem. Now remember, every time I see an r, I'm going to replace it with some substitution involving h. So if my h equals 4r, then that would mean that my r would be h divided by 4, or 1/4 of the height. So when I come across my radius here, I'm going to take that out, and in its place I'm going to plug in h divided by 4. When I square a fraction, I need to square the numerator and the denominator, so that's going to be h squared over 16. And when I simplify all this the best I can, my answer is going to end up being pi times h cubed all over 16. And so this is just an application of us rewriting a function to get some particular letter by itself. Alright, we'll work on these problems tomorrow as well in class. If you want to get a little bit of a head start and practice some of these, our problems are going to be on page 79. and we're going to do problems 39 through 84. Do as many of those as you need on that page, and again, we'll work on those a little bit in class tomorrow as well. Alright, good luck. If you have any questions, let me know. Thanks. Have a good one.